A really interesting kind of quirk happens, a quirk of mathematics. I find these things really interesting, but they do exist. It's kind of like the gradient in neural networks. How if you just give your network an error, it seems to learn better, and there's not a lot of it's weird that the first person that figured out that quirk, but it's an interesting quirk and it works well to train neural networks. Same thing here. Central limit theorem is an interesting quirk of mathematics that allows us to validate how much uncertainty we expect in our data. Okay, so the idea is by random sampling, we're going to essentially, if you were to draw enough random samples and then plot the mean of the average or plot the distribution of averages, min, max, any summary statistic will be collected and will distribute a normal distribution. Will be in a normal distribution. Okay, so we're going to sample, collect averages. What will happen is the emergence of normality. So we kind of start to see as we collect more of these averages, we'll start to get a more perfect normal distribution. So this happens regardless of the original distribution. If it was an exponential, abnormal, normal distribution, we'll get the normal distribution from plotting this. And this, because it's always going to be that same shape, we then are able to use hypothesis testing or hacker statistics to brute force the hypothesis testing to get a very similar answer to what our understanding of is the uncertainty in our data set.